Alright, the next thing we're going to start working on deals with slope. So, we're going to figure out how to calculate slope in this video for today's lesson. So it says, Introduction to Slope. The x and y intercepts represent the point where a line crosses the x and y axes. Another important feature of a line is its slope. Geometrically, the slope of a line measures the steepness of the line. So we focused already on x and y intercepts last week. You guys know how to calculate and solve for those. Now we're going to look and see how we figure out what the slope of a line is. So to help you think of this, think of skiing when working with the slope. And let's pretend that you were skiing. This is the beginner's hill, and this is the daredevil hill. By visual inspection, daredevil's hill is steeper than beginner's hill. To measure the slope of a line, you consider 2 points that are on the line. The slope of the line is the ratio. Remember, ratio just means fraction. Of the vertical change, the up and down change, or change in y, between the 2 points, and the horizontal change, the change in x. Horizontal is side to side. So slope is your ratio or fraction, the change in y values, up and down, your rise, over your change in x values, left to right, which is your run. So if we have points, we can actually calculate the slope of things. So let's take a look here. To move from point A to point B on beginner's hill, you rise, you go up 2 feet, and then over 6 feet. So my change in y, I went up 2, and then my change in x, I went over 6. So it's 2 over 6, and I can reduce that to be 1/3. To move from point A to point B on Daredevil Hill, I rise 12 feet, so I'm going much higher, and I'm only going over 6 feet. So my change in y values are 12, and my change in x is 6. 12 divided by 6 is 2, so I can reduce that to 2. The slope is 2. So then you can look, Daredevil Hill has a bigger slope than Beginner Hill. Its slope is a larger value. So let's start calculating slope. Remember, keep that idea of skiing in mind because it'll help you when you're doing your problems. So flip over your sheet to this page. And it's asking you to find the slope between the labeled points, and then it gives you some spaces to do your work. So here's a line, and I've got 3 points on it currently, A, B, and C. When you're looking at a graph, you always look from left to right. So I always start on this side, and then I'm going towards the right, just like when you're reading. So to get from point A to B, we have to count how am I going to get from A to B, and you always go up or down first, and then right, to the right. So this one says, to get from A to B, you move blank spaces up. So if I'm counting, I'm going to make what's called a little slope triangle and count how many spaces up I have to go from A to get up to B's level. So this is 2 spaces up. And then how many spaces to the right? 3 spaces to the right. So my slope, my change in my y over my change in my x is 2/3. To get from B to C, let's see, so to get up from here to B, that looks like that's 4 spaces. And then going over to C, 1, 2, 3, 4, 5, 6 spaces. So I move 4 units up and 6 units to the right. Now be careful with your fractions, we got to make sure that if we can simplify them or not. So let's use our calculators and see if we can simplify that one. Alright, so with your calculator, you're going to type in the fraction. So I'm going to type in 2 divided by 3 just to check and hit enter, and you get that decimal. To convert it into a fraction, there's a button on the graphing calculators where you hit the math button, and then you hit number 1 for fraction, and that gives you the reduced fraction. So 2/3 is already reduced. But let's check out 4/6. 4 divided by 6, enter. Math, fraction, enter. This one also reduces into 2/3. So what does that tell you? What relationship do you see between the slopes? Well, they're the same. They have the same value. So what that means is that no matter where you are on this line, any distance between 2 points on this line is going to be the relationship of 2/3. You should be going up 2 over 3 for this line. So for each example, shade the slope triangle. The triangle should always be drawn such you move up or down and then to the right. So you're always going up or down first and then to the right. So just like here where I made my slope triangles, I went up or down and then to the right. In this case I happen to go up. We'll look at some examples where we might go down. Okay, let's try the next couple. To get from L to M, you move blank units up and how many spaces to the right? Let's see. 1, 2, 3, 4, 5, 6. I count 6 spaces up and 2 spaces to the right. And I can reduce 6 divided by 2 is 3. You always want to leave your numbers as fractions or as whole numbers, never as decimals. Alright, to get from J to K, I'm going 3 units up and 1 unit over. And there's my slope triangle. Three over 1, which gives me 3 again. So again, what relationship do you see between the slopes? They're the same. If you wanted to check that, you could try going from K to L and see if you get 3, or even go from K to M and see if you get 3 when you do the fraction. But you should always get the same value. And then the last one. Find the slope between the labeled points. This time we have to go down, because as I'm moving from left to right, this line is going down. And when you're going down, we use negatives. So anytime you go down, it's a negative value. So to get from R to S is right here. I'll make my slope triangle. I'm going down 1, 2, 3, 4 spaces. And I went over to the right 2 spaces. So I moved 4 units down and 2 units to the right. So it's negative 4 over 2, which is negative 2. To get from Q to T, you move. So let's do Q to T. So counting from Q going down, I have 1, 2, 3, 4, 5, 6, 7, 8. 8 spaces down, and 1, 2, 3, 4 spaces to the right. So 8 over 4, negative 8 over 4 is negative 2. So again, we have the same value, and that's how you know you did these correct. They have the same value. Okay, so I'm going to have you work on the practice problems now. For the practice problems, there's 2 sides. The first side is just, I've given you some lines. You have to find the slope between the lines. Excuse me, the slope between the points. And then for the last problems on the back, I'm giving you coordinates. And then you're going to have to graph the coordinates onto the sheet over here and find the slope between them. There's only 4 graphs to use, so you're going to probably have to do a couple examples on each one. Probably you could do 2 examples on each. So graph 2 of them on each graph. So let's say like this is number 1 and 2, 3 and 4, and so forth and so on. Okay? Get to work.